Hello everybody, welcome again to another wonderful episode, and in this tutorial I'll be taking you through how to create a cartography map, then placing inset plots which would convey information on some time series or some other statistic. And there's a more, should I say, fancy way of visualizing, let's say, some particular data, but then it's also quite scientific and you're able to fuse lots of information directly over your cartography map or your geographical map. And so to start off, we import XRA since we'll be dealing with I'll be making use of a NetCDF data. I want to use XRA to make that easy. That's a simple package to use. And then also cartography for creation of the map. And then also I'll be needing the cartography feature because I'll be including the country borders. And I'll make use of the matplotlib.py plot for the plot environments. And then there's a new item I would make use of, which is the MPL toolkits, MPL toolkits, and then I'll make use of the child package, which is the axis grid, and then also another subchild, which is the insert locator. And from that, I'll be making use of insert position and then zoom insert axis. Now this is just to help us create our insert plots. So to start off, let's call our input file and then call our data by using XRA, which we've imported, then running that on open data set on the in file we've created. Okay, so we can run this whole thing. Okay, so while it's running, we can just create our figure environment plt.figure. And then I want to create a fixed size. And use an 18 by 10. That's a very huge figure panel. And then next, I'll create my axis. So AX equals to plt.subplot. And this is going to be the main mapping interface. So I'll just use 1, 1, 1. That means 1 by 1, and then placing it on the only index we're having. So that's like a huge panel. And then create the projection, which is from the CCRS we've created. And then I'll use the plate carry projection. Okay. Okay, so this is done running. Okay. So now we can include our coastline. So ax.coastlines. Then we can indicate the resolution. So resolution equals, let's use 110 M. Okay. So now if I run this whole thing, at least the inclusion we have, we can see how our plot looks like for now. Okay, so that's our interface. Mapping feature showing all the coastlines. Now I want to thicken the coastline, so let me add a line width. And already a black color, so I would maintain the black. All right. Now the boundaries get thicker. Right. I'm going to set an extent, but then what I'll do here is I could have just done AX that set extent and then keep the extent in the as a whole list, so like an array. So I could just put in the values. But what I want to do is to just use other variable namings to represent them. So let me call this left, right, bottom, then top. And up here above it, I'm going to specify the values. Now this is very necessary because I'll be using these values again in the inset creation. And I wouldn't want to then recreate them. I just want to use them directly as it is. So that's why I have to assign their values here first. Okay. Okay, so this should cut out a huge part of Africa, like the whole continent of Africa. Yeah, exactly. All right, so now we can add our country borders. So AX dot add feature. Then from our CF, we now import borders. Okay. So if I run everything, now we'll see the country borders shown. All right. Now, I want to do away with the bounding box, the rectangular line around the map. So to do that, I'm going to use a PLT feature and then GCA, open brackets, dot outline underscore patch. And then from there, I set visible. That's whether it should show or not. Now this is a Boolean, so I'll use either true or false. True to show, which is the default, and then false to turn it off. So if I run this, I should have the bounding box off, and that's what we have over there. Right. So this is for the background map. Okay. And now we go on to the inclusion of the inset. I want us to write it out first using a fixed point, and then from there we'll look at how to pass it into a function. All right. Now before this end, I would want to create my, in order not to be typing my longitude and latitude all the time, I would want to assign them to particular values. So particular variables. So let's say this is the station's longitude. Now I want to use a fixed value for now. Let's assume a fixed value of 0.25. And then the latitude. So our station latitude, we assume a value of 5.75. Right. Now we can go down. So before the axis, before the insert, I can then at least show a point on the location we are pulling the data out to create the time series as the insert. So we can just do AX because we created the axis for figure 1, AX.plot. Then longitude against the latitude, which we are plotting with, let's just say black circles. Right, so we see a circular point on the border. At least I think that's somewhere close to Accra in Ghana. Right. We can now include our insets. So we are going to create a new axis. which is AX2, and this will make use of the zoomed inset axis. Zoomed inset axis. And then we are going to create this zoomed inset axis from our main axis. So it should be an inset based on the main. So our main axis is our AX from line 26. So we pull that on our AX. And then you can also indicate your zoom ratio. So how magnified it should be. So we indicate zoom, and let me fix here a value of 20. The other attributes you can place in there. All right. Now, what happens when we are creating the inset is that because we said it should be zoomed from this main axis, which is the AX, even though we are creating a new AX2, this AX2 would be based on the main AX. And so what it's doing is that the whole bounding area. Okay, so if I should disable this line 31 first, and then I run this whole line, it would see a bounding box. What that means is that the whole bounding box becomes the dimension for the new inset. And so we would want to scale the measure of each part of the box by the extent of the map. So that if I want this projection or this point, I want data from this point to be shown exactly within that same area, I'll need to use the extent as a weight on the new dimension. What it does is from this new box, it starts from the lower point on the left also being 0, and it increases all the way to 1 on the right. 0 increases all the way to 1 on the top. So you have 0 to 1, 0 to 1, left and right. Okay, so we can now disengage 31 to take off the bounding box. All right. So now what we are going to do is to use our arguments created on the line 28 to identify the position of the inset. So we want to automatically create it so that we don't need to put in the values like fixed values or calculate the ratios ourselves in our mind. So we'll try first, let's create the X position for the inset. Now I'm going to use the left. So the X is moving left to right. So what I'm going to do is to find first an absolute of the left. So if it's a negative, it's going to pick its absolute value. If it's positive, still its absolute value. And then I would add that to the longitude that we selected. Okay, so and put all this together in one parenthesis. And then I'm going to divide this by what the actual extents are, the sum of the extents. So that will give us a range of the extents on the main AX. So that will be a weight on the new positioning we want. Okay, so the weight of that would be having an open parenthesis, and in that I'd have the absolute of the left plus an absolute of the right. Now we do the same thing for the y, but this time we are not using left and right, we are using the top and bottom. So I use the bottom and then add the latitude so that it moves all the way from the 0. The bottom is the 0 mark. Then add the latitude point we selected onto it. So this would be bottom, absolute of bottom plus the latitude plus the absolute of the bottom again, then absolute of the top. So the sum of the absolute of the bottom and the top would be the total range that will serve as a weight on the y. Now we need to set our inset position. So let me call this IP, which is the inset position. And then I make use of this inset position package. So I call this, and then now I indicate that the inset should be created on the AX, which is the initial axis we set. Now I need to open a square bracket here, and I indicate my position of the X, which is the one we created, and then the Y position, that's where I should place them. And then I also indicate its size, I mean the width and the height. So first I indicate the X size and then also the Y size. So let me use a size of 0.2. That's how either how huge it should the inset should be on the X-axis, and then 0.1. That's how high the plot should be, the inset plot should be. And then now in here I've only created the position, so I need to set the axis locator of that position on the new AX we created. So we have AX2, which is what we created from 35, dot set axis locator. And then we are setting it based on the IP. So now if I run this, I should have a blank box created on my new position that's close to our point. All right. So we have this, and we see that directly by the point, there's a new box created. And now in this new axis, or in this new box, that's where we are going to put our time series for the location we've selected. All right. So I can duplicate this multiple times over different locations, and that's as easy as it gets. All right. So now let me call the data from this same portion as new det. So that's like a new data. And then I'm just going to call the data, and then the variable in that data we'll be using the TMP. And I select from the longitude we've selected, so ST under long, and then the latitude also ST under lat. Like I always have been saying, we include a method nearest. That is because if the location we've selected doesn't by default exist in our NC file, we would use the closest location as reference for the location we selected. So it's going to employ more like a nearest neighbor algorithm to select that range. Now this is a monthly data. I want to employ a rolling mean to make it more like a moving average on the yearly basis, on the 12-month basis. So I include the rolling here, and then I set the window. That's 12, that means 12 months rolling mean. Then I indicate the mean. Right. Now that that is done, on my next line, I'm going to plot the new data. So new det dot plot. And in plotting, I have to set the label. So label equals, I'm going to use, okay, let's call this the label definition. And what I'm going to do is I'll create the label definition above it. I could have just put it in, but just to explain something. Now, let's assume we have a station name directly specified here. So let's say this station is Accra. Now, all I want to do is for this label, I want to include the station as part of the name, which is a string. And then I also want to place in the slope. This will just be on the legend. Okay, I'm creating a label that we'll be needing in the legend. I want to directly indicate maybe a statistic. So let's import our Pyman candle, for instance. So we import our Pyman candle as PMK. Then let me run this line so that I don't forget. So Pyman candle is imported. All right. So let's place here statistic. And the statistic I'm going to use is from the PMK. So PyMank and I call the original test. On the new data we created. And then all I need in here is the slope. Okay. And then I want to round out this whole slope so that if it's so huge, I don't need everything there. So I would make use of the numpy. Let me import numpy here as np. And then run just that line so that it's also imported. All right. So around this PyMank and DAO line, I'm going to round the value. So np.round. And then I round this whole statistic to, let's say, 5 decimal place. All right. So now our label definition is our station, which is a string, plus we're going to now add another string. We just open brackets. We are adding brackets directly into the label. So we add the brackets directly to the label. So we put the bracket in the single quotes. You can also use double quotes, and we do same here. Now, between this single quotes, I want to fix the statistic, but then as a string, so string of the statistic. Because bear in mind, we are only concatenating strings here. So without a string on the statistic, it means this will be either a float and that would produce an error. All right, so now that we've created this, means our label is created for the plot. So we can now go, as part of the plotting, we can include the color of the line, our plot line. Let me just include a default color of black. So we have like a black time series. So we can run this whole section. Okay. Okay, let me run just line 42 to 45 and see what that produces, not on the inset. Oh, okay. Okay, so I didn't run the station, so let me rerun this station and rerun that whole set of line. Okay, so yeah, so I think the problem was because I didn't run the line 23 first. So he didn't know which station, which variable was termed as station. All right, so we just have our inset shown directly. Now what we want to do is to format, let's say, the inset plot. I would want to remove the labels on the x-axis and then also change the title. So that is something we could easily do. So directly from the end of the line, we can then employ plt.sticks. And then I would open a blank and replace it with a blank. So that would remove all the ticks on the x-axis of our new inset plot. So yeah, that's it, it's gone. And then I also want to take off the time label we are having down there. So to do that, I just change my plt.x label to a blank. Right. Yes, so that's it. It's gone. But then after creating our plot, we should also include the legend. So that's the label we created shows. So plt.legend. Sorry, let me use the AX2 because I'm setting it on the AX2 axis. So AX2.legend, and then the location where it should place it. I just want it to be, picking the best location depending on where there's availability of space. So I set LOC to 0, and then I indicate the font size of the legend to be 11. Okay, so let's run this whole line. Yes, so that's what we have for our inset. But then I want to do away with the line so that it shows only the station name and then the slope value. So as part of the legend, I would also include the handle length. And then I set the handle length to 0. So if I run this, there shouldn't be any line, just the name of the location and then the slope. All right, so that's what we have over there. Okay, now let me place this. Instead of using the best location, let me set this to, I think 1. So I position it on the top right, I believe. Okay, so I think that's quite okay. All right. We also want to remove the title of the plot. So we set plt, the title, to blank. And that's how you add an inset directly to the plot, which is quite easy. And that's all. And with this, we should be done. Okay. Now, if I want to replicate this or reuse this code, it means I would always have to type this whole line for a new inset. That's for the line 36 all the way down. I need to include that for a new inset. So what I'm going to do is to build this as a function. Now I'll include the tutorial that looks at how to build functions in Python. That'll be quite easy to deploy. So what I would need is to first create my function, which is the def, and then give the function name. So let's say maybe give it any function name, insert image, right? Insert image, and then there are some dummy arguments I'll be using here. Okay, so let me call this dependent on one station, should also depend on the longitude we set, should also depend on the latitude we set, then also depend on the left, the right, the bottom, and then the top. And then we want to use specific colors for specific locations. So we can also include, let's say, the line color as a dummy argument, which would be a string. Now I need to indent all the lines that follow under the function so that they are captured as part of function. And then because of the line color I would use here, I want it to show for also line 34. So I'm going to bring line 34 as part of the function, and that should be my first line. So I'll bring that as part of the function. Now, instead of using the KO, I'll just indicate the marker. The marker should be circles, and then the color should be the L call we would be included. So if I include a color of green, it will use the line, the point would then be a green color. And then would be also using the same thing here. Let's say in place of the title, I would want to put the station name there. So station And then the color for the station should also be the same as the L core. All right. I think everything else is done. Yep, I think everything else is done. And then where we added the legend, you can also include a face color so that it sort of shades, it gives a different shade to the legend. So I can include face color to be equal to the same as the L core that will specify. All right. Now with this as a function, it means the function can be positioned anywhere. I can place this directly above every other thing before I even start working in here. So let me make that easy. So, okay, let's just leave this for now. And all we'll be doing is, in order to call the function, we are going to call the function name. So insert image, and then we would specify the station. Let's say this is Accra. And then the second argument is the longitude. So we put in the value, let's say 0.25, the latitude 5.75. Oh, and then we specify our left, right. In fact, left, right, and then bottom and top are already taken from here. So I can just put them as the name is. So left, right, bottom, and then top. And then I indicate the line color, B, for blue, okay? Now if I run this whole line, this is what I will see. So we have Accra above it, you know, a shade of blue here because I said the face color to be blue, okay? If you don't want that, we can delete that from this face color as part of the legend. And then also the point, you see that the point is also a blue color. And that's how you attach insets. So that's quite easy. We've also employed the function to make our replications quite easy for us. Now let me include another inset on the same map, okay? So I need a coordinate. Let's see if we can get maybe some other location. Let's see. All right, so we are adding a location, let's say Johannesburg, and then the coordinates, that's the longitude, we have 28.047 east, then the latitude also 26.204 south. Now our left, right, bottom, top will be maintained because we've already set them as their extent. So you see how good it was, we set it here. So we don't need to be changing it all the time or typing it in all the time. And then now I'd want to use a different shade. Let's say I want a magenta fill over here. And then I also want to, we can keep the face color, but then I just want to take it off for ease. All right, so now it means because of what we've done, I don't need the line 22 and 23 to be fixed because I then specify what the coordinates are. All right, so if I run this whole section, because I don't want to run through everything because we've run the top already. If I rerun this whole part, I should have two different insets on our main geographic background. Well, it's taking a bit of time. But I hope it will be done soon. All right. Okay. Well, I did something wrong. So I actually said south, but then I fixed in a north location. So 26.204 here is south. So that should be a negative. Yeah. So it was my own fault. So let's rerun it and then see what we get. taking another time. All right, so that's it. So we have that of Accra showing with its time series. And then we also have that of Johannesburg showing with its time series. And that's simply how to create sort of a geographic map with insets of your time series. If you also don't need the legend showing, because this is quite huge, you can comment that whole legend and then you have just your image. You can include the statistic as part of the title. Okay, so let's try that approach. So let me comment out this legend so it doesn't show. And then rather I would set the title as the lab, that's the label definition. Okay, and then we can just rerun this finally and see how the output looks like. Okay, so that is it. All right, and then we are done. At least we see what the trends are. I mean, the temperature trends are over Accra, temperature trends over Johannesburg. We can do same for various locations. And that's just to address the question that was asked by one of our subscribers on how to overlay insets, or let's say insets of the time series on a geographic map. So there's one approach. The next time we'll look at how to probably position the time series somewhere away from the geographic map and then try to trace a line from the insets plot directly to the point. So I hope you enjoyed this tutorial. Like I always say, there's more to learn ahead. So keep pushing yourself, get better at it. And if you have any question, leave it in the comment section and we'll try to address it. So my team and I will try to address it. And we hope we answered your questions. Don't forget to subscribe if you haven't already. Click on the notification bell to always get updates from us whenever there's one release. And leave a like, leave a comment, and keep learning, keep being better. Have a wonderful time. Bye-bye.